Students, in this class, we will study about the square root of a complex number. Now, if you are given, say, 16 and x is the number, and you are asked to find the square root of x, then you're going to be writing it as root of 16, which is equal to plus or minus 4. Okay. Now, this x is actually a real number. But what if they give you, say, some z is equal to a positive ib, and they are asking you to find the square root of this complex number z? How would you do that? So, in this class, we would be learning how to find the square root of a complex number. So, the solution is obtained as follows. So foremost, I'm taking, let z be the complex number, a positive ib, and let its square root be x positive iy. So what is the meaning of this? The meaning of this is root of z, which is nothing but square root of a positive ib, is equal to x positive iy. So what we would do is we would start off by considering root of a positive ib to be equal to x positive iy. Now, squaring both sides, what do we get? When we square both sides, we get, this is going to be root of a positive ib raised to the power 2, and on the right, this is going to be x positive iy raised to the power 2. Okay. Now, square root and square gets cancelled, giving you a positive ib is equal to, on this side, it's going to be x squared positive I times 2xy and positive I squared y squared. So this is rewritten as x squared. I squared is negative 1, so I'm going to write it like this: x squared negative y squared positive I times 2xy. On the left, it's going to be a positive ib. Now, equating the real part and the imaginary part, we get. So what do we get when we do that? We get a is equal to x squared negative y squared and b is equal to 2 times xy. Now, remember one thing, just for your information. We have taken z to be as a positive ib. Now, if I were to take the modulus of z, that is going to be root of a squared positive b squared. Now, why am I showing you this? Because we will be using this later on. So, we will be using this equation, x squared positive y squared raised to the power 2 is equal to x squared negative y squared raised to the power 2 positive 4 times x squared y squared. So, this equation we will be using. Now, we know that x squared negative y squared is equal to a. We already know from the previous working. And we know that 2 times xy is equal to b. Okay. So, we would use these two into this equation. So, therefore, if I were to take this as 2, therefore, 2 becomes x squared positive y squared raised to the power 2 is equal to a squared positive. Now 4x squared y squared. I got the value for 2xy. So this is going to be b squared. Okay. Now from here I can rewrite this to be as x squared positive y squared is equal to root of a squared positive b squared. So I would be using this 3. Let me take this as 1. Okay. Using 1 and 3, we get, so what do we get? We got 3 here, and 1 is going to be x squared negative y squared is equal to a. Now, we would be solving them. Okay, so negative positive gets cancelled, giving me 2 times x squared is equal to, so this is going to be root of a squared positive b squared. Okay, and that has to be added because the sign is, I'm not changing any signs, so the sign of a is positive. So from here I get x squared is equal to root of a squared positive b squared positive a divided by 2. Therefore the value of x is equal to root of a squared positive b squared positive a divided by 2. So this is what I get. Now from here you can easily find the value of y, or in other words we would make the substitution for x and find the value for y. Substituting in 1 we get, so what do we get? We got x squared negative y squared is equal to a. This is what we have got, but we need to know the value of y. So from here I can write y squared, interchanging, this is going to be x squared negative a. So if I were to substitute the value for x squared here, this is going to be root of a squared positive b squared positive a divided by 2 negative a, this is my y squared. So this is equal to root of a squared positive b squared positive a negative 2a divided by 2, which is root of a squared positive b squared negative a divided by 2. This is my y squared. So therefore y is going to be equal to root of a squared positive b squared negative a divided by 2. But we know, WKT stands for we know modulus of z is equal to root of a squared positive b squared. I've just showed you during the problem. So this is going to be, therefore x is going to be, I'm going to substitute modulus of z. So it's going to be root of modulus of z positive a divided by 2, and y is going to be root of modulus of z negative a divided by 2. So we got x and we got y. Now when we started the problem, we assumed that z to be equal to a positive ib and x positive iy to be the square root of a positive ib. So the meaning of this is the square root of a positive ib is actually x positive iy. Now for x we can simply substitute the value that we have got. It's going to be root of modulus of z positive a divided by 2 positive. But when we are substituting the value for y, we will have to place b divided by modulus of b. Of course there is an I there, and that has to be multiplied with the value of y, modulus of z negative a divided by 2. This is used to counter the sign of a and b. If a, the signs of a and b can change, can vary. So to counter that signs of a and b, we will be using b divided by the absolute value of b. So that is the reason. Of course, we need to place plus or minus, because whenever you take square root, you have two values, plus and minus. So that's why I'm placing the sign plus or minus. So this is the formula that we should use whenever we are asked to find the square root of a complex number. So in the next class, I will show you how we could apply this formula.